A gun turret is a weapon mount that protects the crew or mechanism of a projectile-firing weapon and at the same time lets the weapon be aimed and fired in many directions. The turret is also a rotating weapon platform. This platform can be mounted on a fortified building or structure such as an anti-naval land battery, or on a combat vehicle, a naval ship, or a military aircraft. Turrets may be armed with one or more machine guns, automatic cannons, large-calibre guns, or missile launchers. It may be manned or remotely controlled, and is often armoured. A small turret, or sub-turret on a larger one, is called a cupola. The term cupola is also used for a rotating turret that carries a sighting device rather than weaponry, such as that used by a tank commander. A finial is an extremely small sub-turret or sub-sub-turret mounted on a cupola turret. The protection provided by the turret may be against battle damage, or against the weather conditions and general environment in which the weapon or its crew will be operating. The term comes from the pre-existing noun turret, a self-contained protective position which is situated on top of a fortification or defensive wall, as opposed to rising directly from the ground, when it constitutes a tower. Warships. Before the development of large-caliber, long-range guns in the mid-19th century, the classic battleship design used rows of port-mounted guns on each side of the ship, often mounted in casemates. Firepower was provided by a large number of guns which could only be aimed in a limited arc from one side of the ship. Due to instability, fewer larger and heavier guns can be carried on a ship. Also, the casemates often sat near the waterline, which made them vulnerable to flooding and restricted their use to calm seas. Turrets were weapon mounts designed to protect the crew and mechanism of the artillery piece and with the capability of being aimed and fired in many directions as a rotating weapon platform. This platform can be mounted on a fortified building or structure such as an anti-naval land battery, or on a combat vehicle, a naval ship, or a military aircraft. History. During the Crimean War, Captain Cooper Phipps Coles constructed a raft with guns protected by a cupola and used the raft, named the Lady Nancy, to shell the Russian town of Taganrog in the Black Sea. The Lady Nancy proved a great success, and Coles patented his rotating turret after the war. Following Coles' patenting, the British Admiralty ordered a prototype of Coles' design in 1859, which was installed in the floating battery vessel, HMS Trustee, for trials in 1861, becoming the first warship to be fitted with a revolving gun turret. Coles' design aim was to create a ship with the greatest possible all-round arc of fire, as low in the water as possible to minimize the target. The Admiralty accepted the principle of the turret gun as a useful innovation, and incorporated it into other new designs. Coles submitted a design for a ship having 10 dome turrets each housing 2 large guns. The design was rejected as impractical, although the Admiralty remained interested in turret ships and instructed its own designers to create better designs. Coles enlisted the support of Prince Albert, who wrote to the First Lord of the Admiralty, the Duke of Somerset, supporting the construction of a turret ship. In January 1862, the Admiralty agreed to construct a ship, the HMS Prince Albert, which had 4 turrets and a low freeboard, intended only for coastal defense. Coles was allowed to design the turrets, but the ship was the responsibility of the chief constructor Isaac Watts. Another of Coles' designs, HMS Royal Sovereign, was completed in August 1864. Its existing broadside guns were replaced with 4 turrets on a flat deck and the ship was fitted with 5.5 inches of armor in a belt around the waterline. Early ships like Monitor and the Royal Sovereign had little seakeeping qualities, being limited to coastal waters. Coles, in collaboration with Sir Edward James Reed, went on to design and build HMS Monarch, the first sea-going warship to carry her guns in turrets. Laid down in 1866 and completed in June 1869, it carried 2 turrets, although the inclusion of a forecastle and poop prevented the guns firing fore and aft. The gun turret was independently invented by the Swedish inventor John Ericsson in America, although his design was technologically inferior to Coles'. Ericsson designed the USS Monitor in 1861. Its most prominent feature was a large cylindrical gun turret mounted amidships above the low freeboard upper hull, also called the raft. This extended well past the sides of the lower, more traditionally shaped hull. A small armoured pilot house was fitted on the upper deck towards the bow, however, its position prevented Monitor from firing her guns straight forward. One of Ericsson's prime goals in designing the ship was to present the smallest possible target to enemy gunfire. The turret's rounded shape helped to deflect cannon shot. A pair of donkey engines rotated the turret through a set of gears. A full rotation was made in 22.5 seconds during testing on February 9, 1862. Fine control of the turret proved to be difficult as the engine would have to be placed in reverse if the turret overshot its mark or another full rotation could be made. Including the guns, the turret weighed approximately 160 long tons. The entire weight rested on an iron spindle that had to be jacked up using a wedge before the turret could rotate. The spindle was 9 inches in diameter, which gave it 10 times the strength needed in preventing the turret from sliding sideways. When not in use, the turret rested on a brass ring on the deck that was intended to form a watertight seal. In service, however, this proved to leak heavily, despite caulking by the crew. The gap between the turret and the deck proved to be a problem as debris and shell fragments entered the gap and jammed the turrets of several Passat-class monitors, which used the same turret design, during the First Battle of Charleston Harbor in April 1863. Direct hits at the turret with heavy shot also had the potential to bend the spindle, which could also jam the turret. The turret was intended to mount a pair of 15-inch smoothbore Dahlgren guns, but they were not ready in time and 11-inch guns were substituted. Each gun weighed approximately 16,000 pounds. Monitor Euro-S guns used the standard propellant charge of 15 pounds specified by the 1860 Ordnance for targets distant, near, and ordinary, established by the gun's designer Dahlgren himself. They could fire a 136-pound round shot or shell up to a range of 3,650 yards at an elevation of +15 degrees. HMS Thunder represented the culmination of this pioneering work. An ironclad turret ship designed by Edward James Reed, it was equipped with revolving turrets that used pioneering hydraulic turret machinery to maneuver the guns. It was also the world's first mastless battleship, built with a central superstructure layout, and became the prototype for all subsequent warships. HMS Devastation of 1871 was another pivotal design, and led directly to the modern battleship. With the advent of the South Carolina-class battleships in 1908, main battery turrets were designed so as to superfire, to improve fire arcs on centerline-mounted weapons. This was necessitated by a need to move all main battery turrets to the vessel's centerline for improved structural support. The 1906 HMS Dreadnought, while revolutionary in many other ways, had retained wing turrets due to concerns about muzzle blast affecting the sighting mechanisms of a turret below. Another major advancement was in the Conga-class battler cruisers and Queen Elizabeth-class battleships, which dispensed with a Q-turret amidships in favor of heavier guns in fewer mountings. Early dreadnoughts commonly had 2 guns in each turret. However, some ships began to be fitted with triple-gun turrets, with the first to be built with such a design was the Italian Dante Alighieri, although the first to be actually commissioned was the Austro-Hungarian Viribus Unitas of the Tegetthoff class. Ships by World War II were commonly using triple and, in some cases, quadruple turrets, which reduced the total number of mountings altogether and improved armor protection, though quad-mount turrets proved to be extremely complex to arrange, making them unwieldy in practice. The largest warship turrets were in World War II battleships where a heavily armored enclosure protected the large gun crew during battle. The caliber of the main armament on large battleships was typically 300 to 460 mm. The turrets carrying 3 460 mm guns of Yamato each weighed around 2,500 tons. The secondary armament of battleships was typically between 127 and 152 mm. Smaller ships typically mounted guns from 76 mm upwards, although these rarely required a turret mounting. Layout equals. In naval terms, turret traditionally and specifically refers to a gun mounting where the entire mass rotates as one, and has a trunk that pierces the deck. The rotating part of a turret seen above deck is the gunhouse, which protects the mechanism and crew, and is where the guns are loaded. The gunhouse is supported on a bed of rotating rollers, and is physically attached to the ship at the base of the rotating structure. Were the ship to capsize, the turret will not fall out except in the case of the Bismarck, where substantial battle damage and the scuttling charges caused his turrets to fall out. Below the gunhouse there may be a working chamber, where ammunition is handled, and the main trunk, which accommodates the shell and propellant hoists that bring ammunition up from the magazines below. There may be a combined hoist or separate hoists. The working chamber and trunk rotate with the gunhouse, and sit inside a protective armored barbette. The barbette extends down to the main armored deck. At the base of the turret sit handing rooms, where shell and propelling charges are passed from the shell room and magazine to the hoists. The handling equipment and hoists are complex arrangements of machinery that transport the shells and charges from the magazine into the base of the turret. Bearing in mind that shells can weigh around a ton, the hoists have to be powerful and rapid. A 15-inch turret of the type in the animation was expected to perform a complete loading and firing cycle in a minute. The loading system is fitted with a series of mechanical interlocks that ensure that there is never an open path from the gunhouse to the magazine down which an explosive flash might pass. Flash-tight doors and scuttles open and close to allow the passage between areas of the turret. Generally, with large-caliber guns, powered or assisted ramming is required to force the heavy shell and charge into the breech. As the hoist and breech must be aligned for ramming to occur, there is generally a restricted range of elevations at which the guns can be loaded. The guns return to the loading elevation, are loaded, then return to the target elevation. The animation illustrates a turret where the rammer is fixed to the cradle that carries the guns, allowing loading to occur across a wider range of elevations. Earlier turrets differed significantly in their operating principles. It was not until the last of the rotating drum designs described in the previous section were phased out that the hooded barbette arrangement above became the defining turret. Wing turrets. A wing turret is a gun turret mounted along the side, or the wings, of a warship, off the centerline. The positioning of a wing turret limits the gun's arc of fire, so that it generally can contribute to only the broadside weight of fire on one side of the ship. This is the major weakness of wing turrets, as broadsides were the most prevalent type of gunnery duels. Depending on the configurations of ships, such as HMS Dreadnought but not SMS Blah 1/4 share, the wing turrets could fire fore and aft, so this somewhat reduced the danger of crossing the T. Attempts were made to mount wing turrets en echelon so that they could fire on either beam, such as the Invincible and SMS von der Tann battler cruisers, but this tended to cause great damage to the ship's deck from the muzzle blast. Wing turrets were commonplace on capital ships and cruisers during the late 19th century up until the early 1910s. In pre-dreadnought battleships, the wing turret contributed to the secondary battery of sub-caliber weapons. In large armored cruisers, wing turrets contributed to the main battery, although the casemate mounting was more common. At the time, large numbers of smaller caliber guns contributing to the broadside were thought to be of great value in demolishing a ship's upper works and secondary armaments, as distances of battle were limited by fire control and weapon performance. In the early 1900s, weapon performance, armor quality and vessel speeds generally increased along with the distances of engagement. The utility of large secondary batteries reducing as a consequence. Therefore, the early dreadnought battleships featured all big gun armaments of 11 or 12 inches caliber, some of which were mounted in wing turrets. This arrangement was not satisfactory, however, as the wing turrets not only had a reduced fire arc for broadsides, but also because the weight of the guns put great strain on the hull and it was increasingly difficult to properly armor them. Larger and later dreadnought battleships carried superimposed or super-firing turrets. This allowed all turrets to train on either beam, and increase the weight of fire forward and aft. The super-firing or superimposed arrangement had not been proven until after South Carolina went to sea, and it was initially feared that the weakness of the previous Virginia-class ship's stacked turrets would repeat itself. Larger and later guns also could not be shipped in wing turrets, as the strain on the hull would have been too great. Modern turrets Many modern surface warships have mountings for large-caliber guns, although the calibers are now generally between 3 and 5 inches. The gun houses are often just weatherproof covers for the gun mounting equipment and are made of light unarmored materials such as glass-reinforced plastic. Modern turrets are often automatic in their operation, with no humans working inside them and only a small team passing fixed ammunition into the feed system. Smaller caliber weapons often operate on the autocannon principle, and indeed may not even be turrets at all, they may just be bolted directly to the deck. On board warships, each turret is given an identification. In the British Royal Navy, these would be letters, A, and B were for the turrets from the front of the ship backwards in front of the bridge, and letters near the end of the alphabet for turrets behind the bridge shape Y being the rearmost. Mountings in the middle of the ship would be P, Q, R, etc. Confusingly, the Dido-class cruisers had a Q, and the Nelson-class battleships had an X turret in what would logically be C position. The latter being mounted at the main deck level in front of the bridge and behind the B turret, thus having restricted training fore and aft. Secondary turrets were named P and S, and numbered from fore to aft, for example P1 being the forward port turret. Exceptions were of course made. The battleship HMS Agincourt had the uniquely large number of 7 turrets. These were numbered 1 to 7, but were unofficially nicknamed Sunday, Monday, etc. through to Saturday. In German use, turrets were generally A, B, C, D, E going backwards from bow to stern. Usually the radio alphabet was used on naming the turrets, for example, Anton, Bruno, Alberta, Caesar, Dora as on the German battleship Bismarck. In the United States Navy, turrets are numbered fore to aft. Aircraft. History. At first, guns on aircraft were either fixed in orientation or mounted on pedestals or simple swivel mounts. The latter evolved into the scarf ring, a rotating ring mount which allowed the gun to be turned to any direction with the gunner remaining directly behind it. As aircraft flew higher and faster, the need for protection from the elements led to the enclosure or shielding of the gun positions, as in the lobster-back rear seat of the Hawker Demon biplane fighter. The first bomber in the Royal Air Force to carry an enclosed power-operated turret was the Bolton and Paul Overstrand twin-engine biplane, which first flew in 1933. The Overstrand was similar to its First World War predecessors in that it had open cockpits and hand-operated defensive machine guns. However, unlike its predecessors, the side strand could fly at 140 miles per hour, making operating the exposed gun positions difficult, particularly in the aircraft's nose. To overcome this problem, the Overstrand was fitted with an enclosed and powered nose turret mounting a single Lewis gun. As such, the Overstrand was the first British aircraft to have a power-operated turret. Rotation was handled by pneumatic motors while elevation and depression of the gun used hydraulic rams. The pilot's cockpit was also enclosed, but the dorsal and ventral gun positions remained open, though shielded. The American Martin B-10 all-metal monocoque monoplane bomber introduced turret-mounted defensive armament within the United States Army Air Corps, almost simultaneously with the RAF's Overstrand biplane bomber design. The Martin XB-10 prototype aircraft first featured the nose turret in June 1932 roughly a year before the less advanced Overstrand airframe design and was first produced as the YB-10 service test version by November 1933. The production B-10B version started service with the USAAC in July 1935. In time the number of turrets carried and the number of guns mounted increased. RAF heavy bombers of World War II such as the Avro Lancaster and Handley Page Halifax and Short Stirling typically had 3 powered turrets, with the rear near the tail gunner or tail and Charlie position mounting the heaviest armament of 4 0.303-inch Browning machine guns or, late in the war, 2A and M2 light barrel versions of the American Browning M2 machine gunners in the Rolls-Royce turret. During the World War II era, British turrets were largely self-contained units, manufactured by Bolt & Paul Aircraft and Nash & Thompson. The same model of turret might be fitted to several different aircraft types. Some models included gun lane radar that could lead the target and compensate for bullet drop. The UK introduced the concept of the turret fighter, with aeroplanes such as the Bolton Paul Defiant and Blackburn Rock, where the armament machine guns was in a turret mounted behind the pilot, rather than in fixed positions in the wings. The concept came at a time when the standard armament of a fighter was only 2 machine guns. In the face of heavily armed bombers operating in formation, it was thought that a group of turret fighters would be able to concentrate their fire flexibly on the bombers, making beam, astern and from below attacks practicable. Although the idea had some merits in attacking bombers, it was found to be impractical when dealing with other fighters. The weight and drag of the turret impaired the airplane's speed and maneuverability relative to a conventional fighter, which the flexibility of the turret armament could not compensate for. At the same time, conventional fighter designs were flying with 8 or more machine guns. Attempts to put heavier armament in low-profile aerodynamic turrets were explored by the British but were not successful. Not all turret designs put the gunner in the turret along with the armament. Both the Americans and Germans produced aircraft with remote-controlled turrets. In the US, the large, purpose-built Northrop P-61 Black Widow night fighter was produced with a remotely operated dorsal turret that had a wide range of fire, though in practice it was generally fired directly forward under control of the pilot. For the last Douglas-built production blocks of the B-17F, and for all versions of the B-17G Flying Fortress, a twin-gun remotely operated Chiang turret, designed by Bendix and first used on the experimental YB-40 gunship version of the Fortress, was added to give more forward defense. Specifically designed to be compact and not obstruct the bombardier, it was operated by a swing-away diagonal column possessing a yoke to traverse the turret, and aimed by a reflector sight mounted in the windscreen. The intended replacement for the German Bf-110 heavy fighter, the Messerschmitt Me 210, possessed twin half-teardrop-shaped, remotely operated Ferngereichte Druringseitenlaufett FDSL 131 first-speed turrets, one on each side flank of the rear fuselage to defend the rear of the aircraft, controlled from the rear area of the cockpit. By 1942, the German He-177A Greif heavy bomber would feature a Fernbedienbar Drehlaufett FDL-131Z remotely operated forward dorsal turret, armed with twin 13mm MG-131 machine guns on the top of the fuselage, which was operated from a hemispherical, clear rotating astrodome just behind the cockpit glazing and offset to starboard atop the fuselage. A second, man-powered hydraulic Drehlaufett HDL-131 dorsal turret, further aft on the fuselage with a single MG-131 was also used on most examples. The US B-29's Superfortress had 4 remote-controlled turrets, comprising 2 dorsal and 2 ventral turrets. These were controlled from a trio of hemispherically glazed gunner-man sighting stations operated from the pressurized sections in the nose and middle of the aircraft, each housing an altizimuth-mounted pivoting gun sight to aim one or more of the unmanned remote turrets as needed, in addition to a B-17-style flexible man-tail gunner's station. The defensive turret on bombers fell from favor with the realization that bombers could not attempt heavily defended targets without escort regardless of their defensive armament unless very high loss rates were acceptable, and the performance penalty from the weight and drag of turrets reduced speed, range and payload and increased the number of crew required. The British de Havilland Mosquito light bomber was designed without any defensive armament and used its speed to avoid engagement with fighters, much as the minimally armed German Schnellbomber aircraft concepts had been meant to do early in World War II. A small number of aircraft continued to use turrets, however in particular maritime patrol aircraft such as the Avro Shackleton used one as an offensive weapon against small unarmored surface targets. The Boeing B-52 jet bomber and many of its contemporaries featured a tail-mounted barbette, or remote turret, an unmanned turret but often with more limited field of fire. Layout aircraft carry their turrets in various locations, dorsal on top of the fuselage, sometimes referred to as a mid-upper turret. Ventral underneath the fuselage, often on American WW-2 heavy bombers, a Sperry-designed ball turret. Rear, or tail at the very end of the fuselage. Nose at the front of the fuselage. Cheek on the flanks of the nose, as single-gun flexible defensive mounts for B-17 and B-24 heavy bombers, chin a below the nose of the aircraft as on later versions of the Boeing B-17 Flying Fortress. Wing a handful of very large aircraft, such as the Messerschmitt Me 323 and the Blochmann Voss BV-222, had man turrets in the wings, beam, or waist mounted on the sides of the rear fuselage, for example American twin- and four-engined bombers. Combat vehicles. History. The first armoured vehicles to be equipped with a gun turret were the Lanchester and Rolls-Royce armoured cars, both produced from 1914. The Royal Naval Air Service raised the first British armoured car squadron during the First World War. In September 1914 all available Rolls-Royce Silver Ghost chassis were requisitioned to form the basis for the new armoured car. The following month a special committee of the Admiralty Air Department, among whom was Flight Commander T.G. Hetherington, designed the superstructure, which consisted of armoured bodywork and a single fully rotating turret holding a regular water-cooled Vickers machine gun. However, the first tracked combat vehicles were not equipped with turrets due to the problems with getting sufficient trench crossing while keeping the centre of gravity low, and it was not until late in World War I that the French Renault Fort light tank introduced the single fully rotating turret carrying the vehicle's main armament that continues to be the standard of almost every modern main battle tank and many post-World War II self-propelled guns. The first turret designed for the FT was a circular, cast steel version almost identical to that of the prototype. It was designed to carry a Hotchkiss 8mm machine gun. Meanwhile, the Berliet Company produced a new design, a polygonal turret of riveted plate, which was simpler to produce than the early cast steel turret. It was given the name Omnibus, since it could easily be adapted to mount either the Hotchkiss machine gun or the Pitot 37mm with its telescopic sight. This turret was fitted to production models in large numbers. In the 1930s, several nations produced multi-turreted tanks probably influenced by the experimental British Vickers A1E1 independent of 1926. Those that saw combat during the early part of World War II performed poorly and the concept was soon dropped. Combat vehicles without turrets, with the main armament mounted in the hull, or more often in an integral armored casemate as part of the main hull, saw extensive use by German and Russian forces during World War II as tank destroyers and assault guns. However, post-war, the concept fell out of favor due to its limitations, with the Swedish Stridsvagn 103S tank and the German Korn and Panzer being exceptions. Layout. In modern tanks, the turret is armored for crew protection and rotates a full 360 degrees, carrying a single large-caliber tank gun, typically in the range of 105mm to 125mm caliber. Machine guns may be mounted inside the turret, which on modern tanks is often on a coaxial mount, parallel with the larger main cannon. On modern tanks, the turret houses all the crew except the driver. The crew located in the turret typically consist of tank commander, gunner, and often a gun loader. For other combat vehicles, the turrets are equipped with other weapons dependent on role. An infantry fighting vehicle may carry a smaller caliber gun or an autocannon, or an anti-tank missile launcher, or a combination of weapons. A modern self-propelled gun mounts a large artillery gun but less armor. Lighter vehicles may carry a one-man turret with a single machine gun. The size of the turret is a factor in combat vehicle design. One dimension mentioned in terms of turret design is turret ring diameter, which is the size of the aperture in the top of the chassis into which the turret is seated. Land fortifications. Gun turrets have been placed in static, land fortifications such as the Maginot Line forts in France and particularly in coastal artillery defenses such as Fort Drum, the concrete battleship, near Corregidor, Philippines and in Hitler's Atlantic Wall. Some of the artillery pieces in the Atlantic Wall fortifications such as the cross-channel guns were large naval guns housed in large turrets. Some nations, from Albania to Switzerland and Austria, have embedded the turrets of obsolete tanks in concrete bunkers. See also, sponson, barbette, remote weapon system, gun shield, gun mount, gun carriage. Notes. References. External links. Airgunnery November 1943 Popular Science article on aircraft turrets, flight article on aircraft gun turrets amongst others, Lone Sentry's Bendix B-17 Chain turret manual and details.